Hello everyone, this is the next video lecture regarding class 12th chapter surface chemistry. In this lecture we will discuss the preparation of colloids and the purification of colloidal solutions. So as we know that in our last lecture that the colloidal solutions are of two types depending upon the nature, that is lyophobic and lyophilic. So the preparation of colloidal solution, that those are of lyophilic, are very much easy because there are attraction forces between the dispersion phase and dispersion medium. But in lyophobic we use special methods. So in this video lecture I will discuss those special methods with you. These two methods are chemical method and physical method. In chemical method we will use condensation methods, and in physical method we will discuss dispersion methods. So we can say the preparation of colloids is by two methods, condensation method and dispersion method. So first is your preparation of colloidal solution, condensation and dispersion. So what is condensation method? As the word indicates that condensation means combine or aggregate. So basically this condensation method is your chemical method in which the smaller particles of a dispersed phase are aggregated to form large particles of colloidal dimensions. So the type of condensation methods are chemical reactions, by exchange of solvent, by excessive cooling method. So the type of condensation method further divided into three types, in which chemical reaction further divided into four types. Chemical reaction divided into oxidation, reduction, hydrolysis, double decomposition, and condensation also divides in exchange of solvent and excessive cooling. So first method is our chemical method. In this method we will discuss that how the reactions occur. There are four methods which are used for the preparation of colloidal solutions. First is oxidation method, second is reduction method, third is hydrolysis method, and the last is your double decomposition method. So I will discuss one by one these four methods with you. Our first is oxidation method. So as the name indicates, oxidation, you all know that oxidation is addition of oxygen, or we can say the removal of hydrogen. So a colloidal solution of a sulfur is made to pass through an aqueous solution of a sulfur dioxide. It can also be obtained by passing the gas through a solution of an oxidizing agent such as bromine water as well as nitric acid. So in this method we will see that sulfur solution is obtained by bubbling H2S gas. So we bubble H2S gas through the solution of an oxidizing agent like HNO3 or Br2. This is reaction for Br2. This reaction is for HNO3. So we pass H2S from both solutions and we will get the removal of hydrogen, and solution of a colloidal solution of sulfur will obtain in this and in this method. This is your bromine for Br2 and this is for SO2. So these reactions indicate the oxidation in which colloidal solution of sulfur is obtained. Moving to next, reduction. In a reduction method, in the presence of the metal or the solutions of metals like silver, gold as well as platinum takes place, in which the use of reducing agent for the reduction of salt solution of these metals. For example, the reducing agent include stannous chloride. We will use stannous chloride SnCl2 in the presence of gold solution AuCl3, and when they both react they will form the gold sol, which is of a purple color. Similarly, gold solution can be obtained by the reactant of formaldehyde with water. In both the cases reduction take place and we will get a metal solution or a gold colloidal solution. So moving to next, third method, that is hydrolysis. It involves the use of boiling water to obtain a reduced solution of ferric chloride. So what we will see that we have FeCl3, we add H2O, 3H2O water molecule, that is boiling water here, and we get ferric hydroxide solution, that is colloidal. And one more thing, hydrolysis means addition of water. So same is occurring here, the addition of a boiling water to form your FeOH3. Moving to next, double decomposition. Here the word indicates double, means twice. Two times the decomposition will take place. For example, this will move from here to here and this will move from this to this. So formation of water and a colloidal solution will take place by double decomposition when hydrogen sulfide is passed through a solution of arsenious oxide in distilled water, we get a colloidal solution of arsenious chloride. Next is by exchange of solvent. In this exchange of solvent method, as the name indicates, we will exchange the solvent. For example, it involves the formation of colloidal solution of an element by addition of its alcoholic solution to excess of water. For example, we have a solution, and in that solution we will add a water. So what we will get? A colloidal solution. For example, when alcoholic solution of sulfur is made to pass through excess of water, it yields a colloidal solution of a sulfur. It involves the formation of colloidal solution of an element by addition of its alcoholic solution to excess of water. This colloidal formation can take place only when the element is more soluble in alcohol. So we can say that the solutions or the elements which are easily soluble in alcohol can be converted into colloidal solution by adding water in the alcoholic solution of that particular element. This is the exchange of solvent. So in this method we will see that we have this solution, and after addition of a water we will get aggregates and the colloidal solution will take place. Third method is by excessive cooling. In this method, in this technique, we freeze a solution of a water in an organic solvent such as chloroform ether to form a colloidal solutions of ice. The molecules of water find it impossible to exist separately, combine to form colloidal molecules. So in this method we can say excessive cooling, as the name indicates, we cool the solution and by addition of organic solvents chloroform ether, and we get a colloidal formation. Now first method is completed, that is your condensation method. Now we are moving to dispersion method. As the name indicates, dispersion means separation. So in dispersion method, the colloidal particles are obtained by breaking large particles of a substance in the presence of a dispersion medium. Since the solutions formed are unstable, they are stabilized by adding mechanical energy, or we can say electrolytes. The dispersion method in the preparation of colloid can be done by using the crushing of large suspension particles into the smaller particles. So we can say that the dispersion method is a type of a physical method. So these are the further division of dispersion method: by mechanical dispersion, by electrical dispersion, another name is your Briggs arc method, and the third is peptization. So moving to first mechanical dispersion, here we will have a colloidal mill in which we add suspension particles or suspension, and that suspension while moving from this track came here. In these are two discs the suspension particle came, and these two discs move in a opposite direction. One is a clockwise, other one is your anti-clockwise, and that suspension particles get crushed here and get discharged from this end and this end by get converted into smaller particles, as the suspension particles are of larger size. So we can say in this method the large particles of the material whose soul is to be prepared are broken down in a machine which is called your colloid mill. The particles present in the suspension are grinded to form the particles of the colloidal size, and all gets dispersed in water to form a soul. So moving to next, this is the electrical dispersion method. Electrical dispersion method means here we will use electric current, electricity here. So it is the combination of dispersion and condensation. This technique is most commonly used for the preparation of colloidal solutions of metals such as gold, silver, platinum, etc. It involves the use of two metal electrodes dipped in a dispersion medium. So we are having two electrodes, metal electrodes, whose colloidal solution we want to prepare. Then these two electrodes are dipped in a dispersion medium. An electrical arc of intense heat is produced, vaporizing some of the metal, and this electric arc will produce a heat which convert these metal electrodes into a vapor of a metal, and then these metal vapors get condensed, as we are having a ice here in contact with the dispersion medium, which is a water. So we get solutions prepared by this method. This method is known as a Briggs arc method. It is a method of preparing colloids, especially in metallic salts. So two metallic wires function as electrodes immersed in water, then on both ends of wire giving a strong enough current to evaporate the metal, and then that evaporate vapors of a metal get dispersed in water, and by the excessive cooling by the ice we get a solution prepared of a metal as a colloidal solution. So this is what happened. We have a metal electrode, we have a arc, and here we add electrolyte and water in dispersion medium, and this is the ice. So this ice cools the colloidal particles as the metal vapors evaporates from these metal rods after the electric arc. Now third method is by peptization method. As the name indicates, peptization, it is a process of converting a freshly prepared precipitate into colloidal form by the addition of suitable electrolyte is called peptization. And now question is how it will happen. So the precipitates can be converted into colloidal form by shaking with dispersion medium in the presence of small amount of peptization agent. It is an electrolyte used to convert fresh precipitate into a colloidal solution. Such precipitates are aggregate of colloidal particles held by weak forces. So we can say peptization is another method which is used to form the colloidal particles. So it is a process in which a precipitate pass into colloidal solution or adding a suitable electrolyte, and that electrolyte is known as a peptizing agent. For example, we are having a iron hydroxide precipitate and we add FeCl3 solution in this precipitate and we will get a colloidal solution of this. So this is basically the electrolyte used for the purpose of peptizing agent. When we have FeCl3 solution in FeOH3, that is your ferric hydroxide solution, it will form a colloidal solution. So this is a process which is a peptization, and this is the thing that what is basically happening here, that Fe3 positive surrounds this precipitates in this form. Now we will discuss the difference, what is the difference between dispersion method and condensation method, and this will help you to make the clear distinction between two methods. So we discuss condensation method first. So I will start with this. This is your physical state. Here exchange of solvent will take place. Here a chemical reactions take place. And here dispersion method is mechanical dispersion, where electrodispersion method is used, peptization is used, and ultrasonic dispersion methods are used. So in which the breakdown is occurring, and here the condensation will occur. So now our next topic is purification of colloidal solution. We are done with the preparation of colloidal solution. Now how to purify that colloidal solutions which we have just prepared. So here the methods are dialysis, electrodialysis, ultrafiltration, and ultracentrifugation. So moving with first dialysis. Basically dialysis, maximum out of 100, 70% people know what is dialysis. So dialysis is the separation of a colloidal or a colloids from a dissolved ion or molecules of small dimensions or crystalloid in a solution. A colloid is any substance that is made of particles that are of an extremely small size, larger than the atom, but generally have a size of this 10 raised to power minus 7 centimeter ranging to 10 raised to power minus 3 centimeter. Basically I said this that you all out of 100 out of 70 know that what is dialysis, because the person who is suffering from a kidney failure and a problem with the kidney, doctor prefer them for a dialysis. So basically in dialysis what we do, here we have a bag, this is your dialysis bag in which colloidal solution is filled. What we prepared colloidal solution we put here in a dispersion bag or a dialysis bag. This bag is having a pores which is made up of your membrane, you know, semi-permeable membrane in chapter solution. So what will happen, we add solvent from this side, and then that solvent after passing from this dialysis bag, the electrolyte which are extra present in a colloidal solution, which are present in a solution but they are not a part of colloidal solution, they get dissolved in this solvent. Generally we use water. That water dissolve the electrolyte and take away that electrode with it from this bag by passing from semi-permeable and get away from this path, and the colloidal particles or colloidal solution will left remain, because we know that colloidal particles cannot pass from the semi-permeable membrane. So you know that what is dialysis. So now moving to next, what is electrodialysis? So it is just a modification of dialysis. As in dialysis, the process of removal of the particles is slower, the electrolyte is slower in comparison to electrodialysis. So what the current means here, we add two electrodes, positive and negative end. So when we start the current, the electrolyte having here the positive and negative charge particles, they get attracted by these electrodes. Negative get attracted towards the positive rod and positive get attracted toward the negative rod, and the exchange of the excessive electrolyte which are not a part of colloidal solution but they are present as an extra part here will get removed easily by the passing of current. So electrodialysis, here the process of dialysis is carried out in the effect of electric field. Some potential is applied between the metal screens that support the membrane. Due to this potential, the speed of ions moving in the direction of opposite electrode is increased. So we can say, by comparing the both methods, the only difference is with these metal plates or electrodes which are used to apply the current and make the process faster, which is slower in dialysis. Here it will be faster. Moving to next, our ultrafiltration method. Ultrafiltration method is a variety of membrane filtration in which hydrostatic pressure forces a liquid against a semi-permeable membrane. Suspended solids in the solute of high molecular weight are retained while the water and low molecular weight solute pass through the membrane. So what will actually happen? We add a raw water from here. This is our first screen from which molecules of a heavy mass will not pass as much because we are having a hair, we have a hairs of a piece, which piece will not pass the particles of a larger size simply. And then we have a sand filtration will consume little particles of a heavy mass. Then again a microfiltration where the colloidal bacteria will pass through. And then we have a ultrafiltration. This is your ultrafiltration, and here the virus organic micromolecules will also stop. So after passing through ultrafiltration, only the dissolved salt will get here and we get a ultrafiltered water. Excessive things get removed from this raw water. So this is the ultrafiltration, that higher filtration. After simple microfiltration we get a ultrafiltration. So next is our ultracentrifugation. In this, what is centrifugation first? Centrifugation is a technique which is used for the separation of colloidal particles from a solution according to their size, shape, density, viscosity of the medium and a rotor speed. So the particles are suspended in a liquid medium and placed in a centrifuge tube. Then that tube is placed in a rotator and spun at a high speed. So we can say, what is now ultracentrifugation? Ultracentrifugation involves the separation of colloidal particles from the impurities by centrifugal force. The impure soil is taken in a tube and the tube is placed in an ultracentrifuge. The tube is rotated at a high speed. So we can say ultracentrifugation is a specialized technique used to spin sample at a exceptionally high speed. So ultracentrifugation is application in which we will just simply separate out the excessive particles from a colloidal solution. This is the test tube where before centrifugation the particles are here, and after centrifugation we get colloidal particles settled here, and we will remove this material which contain the other unnecessary materials, and we left with our colloidal solution. This is the machine which we known as a rotator, in which we place, this is before centrifugation, and when we rotate this, this is the direction of the machine, and this machine rotates at a very high speed, and when we stop that, we get these particles settled at here, and we have a colloidal solution separated from this, and this rotator is used for the centrifugation. Now we will discuss the properties of colloids. Basically, colloids are divided into three properties mainly: physical properties of colloids, optical properties of colloids, and kinetic properties of colloid. We will discuss one by one every property. The first is properties of colloid, in which we will discuss the physical properties of colloid. So in physical properties, as we know, there are dispersion phase and dispersion medium. So depending upon these, we will discuss the properties of colloid. As the nature of colloid is heterogeneous, so they are not of a same nature. They are of different that is dispersed phase and dispersion medium. So colloidal dispersions are unlike, as we know the nature is different, that they can be detected by a human eye. We can detect by our eye, and even with the microscope we can check the particles. So the size of particle of colloid is too small to be individually seen by naked eye. Sometimes we can check, sometimes we can't. So colloids are big enough to scatter a beam of light passing through it and make it a path visible. They do not settle down when left undisturbed, and that is why they quite are still stable, because they are having a charge separation. That means they are having a similar charged particles which repel each other, and they get suspended in a medium. So the color of the colloidal dispersion is determined by the particles in a solution based on their size, because their size will define the wavelength of light that is absorbed by them and the light scattered by them. So as a result of their size, the colloidal fragment can be passed through a traditional filter paper. However, these particles can be filtered by using the membrane such as animal cellophane or ultrafilters. They are not easily movable or separate by those membranes. So moving to optical properties, the optic word related to the light. So in optical properties we will discuss Tyndall effect, which is related with the light. What we do, we pass the source, and the light is passed from a source. If we pass it from a true solution, we get this type of image, but when we pass a light from a colloidal solution, we get this type of a cone. This cone represents as a Tyndall cone, and we get this thing. So this means that we are having a straight beam of light and it should be like this as it is coming, but as it passed through the colloidal solution, we get this type of, this represents the scattering of a light. So Tyndall effect is defined as the phenomena in which light is scattered by the colloidal particles. The light is being observed by the particles present in the solution. Once the light is being observed, a part of light gets scattered in all the directions, and we will check this type of image which shows that the light is scattered here in a colloidal solution. So we can say that this is the result of a scattering of light, which is possible in a colloidal solution and not in a true solution, because the particle size of a true solution is very less than 1 nanometer, but in colloidal the particle size is more than 1 nanometer. So moving to next property, that is a kinetic property. In kinetic, the kinetic were linked up with the movement. So here we will discuss the movement of the colloidal particle. During the observation of a colloidal dispersion under a ultra microscope, we see the particles are in a continuous movement in the solution. They move in a random zigzag form. So that is known as a Brownian effect. So the Brownian motion arises due to the uneven distribution of the collisions between the colloidal particle and the solvent molecules. This means that dispersion medium and dispersion phase collide with each other. This movement is mainly due to the unique bombardment of the molecules present in the dispersed medium on the colloidal particles. So we can say the Brownian movement was more rapid for the smaller particles, and it decreases as the particle size increases or the viscosity of the medium increases, because if the solution is more viscous, the particle will not move as fast as they can move in a dilute solution. So this is the bombardment. This is a colloidal particle, these are the solvent particles, or we can say these are the dispersion medium, this is dispersed phase, and how this collision occurs, and this represents your dispersion or a zigzag motion. This zigzag motion you can check like this. We can have a dispersion medium which you have studied in your 9th class. What happens basically, the movement is like this. It can be moved in a zigzag motion in any direction. For example, a particle is present at here, and when it strikes with the dispersion particle, it goes there, then it moves here, then it moves here. So it moves in a zigzag motion. This is the zigzag motion which is known as your Brownian movement. So moving to now sum up of the properties of colloidal, that we know they are heterogeneous in nature, they are quite stable one, because they do not settle down, and the reason is I have told you that because they are having a repulsion in the dispersion phase particles because of carrying the same charge. Then they are filterable. Filterability we have discussed. Then colligative properties. Filterability is that colloidal particle can pass through ordinary filter paper because of the pore size is larger and the particle size is lesser. So we use ultra filter paper, in which the colloidal solution cannot pass through, and that filter paper can be formed by just dipping the ordinary filter paper by the gelatin solution and then by the formaldehyde solution, and we will get the ultra filter paper which is used for the filtering of colloidal solution. So this is all what we have studied. Keep watching, subscribe the channel, and stay home, stay safe. Thank you.